Now we will see another example of steel column design with bending. Okay, let us see what it says. A 15 feet long W1296 column is a part of moment frame. This time it is a part of moment frame with column bases that are pinned. That means both ends are pinned. The factored axial load on the column is 250 kips. The factored moment is 120 feet kips about x-axis. The bending is assumed to the building is assumed to be braced. It is a moment frame. At the same time it is braced. Braced means no lateral sway. uh, okay, determine if this column is adequate. So the new in this example is there is no moment about y-axis. No moment about y-axis. It is a moment frame and braced. But as it is braced, we will assume it is a braced condition. Okay, so what is our okay, so if I go back to the design equation, this is our design equation. We should find all the parameters. So pu is given 250, mux is given, my is 0, so both portion is 0. Now which equation, this equation or this one, we do not know. We have to find this ratio. So at the beginning we will find the capacity in uniaxial direction without considering moment. So for KL15, now why K is KL15? Because length is 15 and both column bases are pinned. So it is pin condition. So pin means K is on. So KL is 15. If you go to the AIC manual, we should get this number. Now you might get slightly different numbers because with time this value changes because the coefficient changes. So but I believe that you will get this number or a very close number, whatever it is not a problem. So capacity in uniaxial condition is 990, or load is 250. So again it is okay obviously because it can take more. Oh, another thing, the reason they are telling it is okay because if our capacity in uniaxial condition is less than this, then we do not need to say about moment, because only axial loading it is failing, so we should not proceed. So that is this okay means actually that. Now then we will find the other parameters. This one, moment capacity about about x-axis. How to find it? We need to see the unbraced length. Our unbraced length is 15 feet. From the ASA manual we found LP is 10.9, LR is 46. So our beam is in between. So what is our moment capacity? Our moment capacity is if I so our moment capacity is CB PMP minus P beam factor LP LB minus LP. So that is our moment capacity. So we assume this is 1. This value from AISC manual, AISC manual, this value also from AISC manual, this is from AISC manual, this is 15 feet. Okay, so let us see what they did. So here there is no fee here, but actually there should be a fee. There should be a fee here. Maybe by BF they mean PBF. So they found this from the table and they calculated it's 527, and this value must be less than this portion, that means 551. uh, okay, so we got our moment capacity about x-axis. We are not worried about moment capacity about y-axis. Why? Because I have no moment about y-axis. Okay, next we have to amplify our applied moment. 120 feet kips, we need to amplify it by multiplying b1x. How to find b1x? To find b1, if I go below, this is our equation cmx over 1 minus pu p over p1ex. So this value we learned that we will use 0.85 to be safe, to be conservative. Pu is the applied load, which is 250. This portion is Euler buckling load about x-axis. So Euler buckling load about x-axis. So they found this value, they inserted, and they found b1x is 0.88. We cannot use less than 1, so b1x is 1. So whatever moment given, that is the actual moment. Okay, then we will see which equation to use. As our pu, our ppn ratio is 0.25, again more than 0.02, no, sorry, 0.2. So our equation number 1, we use the equation, this portion it is 0 because there is no moment about y. So after calculating, we got 0.455, which is less than 1. That means, so if I go back to equation, yes, this should be less than 1. That means that column is good. So hopefully you learned this example also. So we will stop here. In the next video we'll see another example, but before going there, again to clarify, there's some issues. So there'll be p here, there'll be p here, and there'll be combined cb, there'll be combined cb as I listed here. Now you apply your own knowledge, whatever you learn, and that should be okay. Okay, thank you again. In next video we'll see one more example.